All right, let's get right into it. Today, we are not just learning about derivative pricing. We're going to build the entire concept from the ground up. Think of this as a masterclass, one that's designed to give you an absolutely unshakable, exam-ready understanding of the core logic. We're going to go way beyond just the formulas to really master the first principles, the technical details, and all the little nuances that separate a good score from a perfect one.
So here's our roadmap for mastering this. We'll start by establishing our theoretical world with what are called the perfect market axioms. From there, we'll fire up the core engine of all pricing, replication and no arbitrage. Then we're going to demystify the concept of risk-neutral probability, and we'll use it to elegantly prove put-call parity. We'll wrap everything up with some crucial exam nuances and a rapid-fire review of the absolute must-knows.
Before we can price anything, we have to define the theoretical perfect world where our models actually work. Now, these aren't just academic details. You have to understand that these are the foundational assumptions that make the entire pricing framework even possible.
First up, a really crucial definition, the self-financing portfolio. Just think of it like a closed system. Any new buys have to be funded by sells. No outside cash is coming in, no money is going out. This is so important because it isolates the portfolio's value, making sure that any change comes only from the performance of the assets inside. This clean tracking of value is the key that unlocks our ability to perfectly replicate a derivative's payoff.
Okay, here they are, the 5 axioms that define our idealized financial world. Number 1, prices are clearly defined. 2, the value of a portfolio is simply the sum of its parts, nothing more, nothing less. 3, trading is frictionless. We're talking no transaction costs, no bid-ask spreads. 4, as an individual, your trades don't move the market. And 5, there are no costs for just holding an asset. These assumptions right here are the bedrock. Everything we build next stands on this foundation.
For your exam prep, here's a simple little tool to lock in these 5 assumptions. Just remember the mnemonic PVTIH. That's for prices, value, trading, impact, and holdings. It's a super quick mental checklist to make sure you never forget the foundations of our perfect market.
All right, now we get to the core engine of all derivative pricing. The central idea here is pretty radical when you first hear it. An options price isn't some subjective guess about the future. Instead, its price is forced upon it by a perfectly replicating portfolio that we build from other, simpler assets. We're moving from prediction to pure construction.
So how is this price enforced? It all comes from the principle of no arbitrage, the famous no free lunch rule. The logic is actually very simple. If you could build a portfolio that, like the slide says, always earns the same positive payoff with no risk, well, everyone would pile into that trade and the opportunity would vanish in an instant. It's this constant market pressure that forces all the prices into a logical equilibrium.
Now, to see this in action, we use a simple framework called the binomial model. Let's just imagine a stock today is at $100. In the next period, it can only go to one of 2 places, either up to 120 or down to 80. That's it. This simple 2-state world is all we need to uncover some incredibly deep truths about pricing.
Okay, now let's overlay a derivative onto this world. Let's consider a call option with a strike price of $90. If the stock goes up to 120, the option is worth $30. If the stock goes down to 80, well, the option expires worthless. Its payoff is 0. So you see, the option's value is completely dependent or contingent on the stock's path.
And here is where the magic of replication happens. Our goal is to build a portfolio of the stock and a risk-free bond that has the exact same payoffs as our call option in both future states. By solving a simple system of 2 equations, one for the up state, one for the down state, we find the precise recipe. We need to buy 0.75 shares of stock and borrow $60. This synthetic portfolio, it is the option, at least in terms of its financial DNA.
Now, this power of replication and no arbitrage, it lets us invent a really powerful mathematical shortcut for pricing. We can step into this theoretical place known as the risk-neutral world, where every valuation problem becomes much, much simpler to solve.
Now, what's so crucial here is that we don't just guess at this probability. We actually derive it mathematically. We start with that no arbitrage condition, and we rearrange the pricing equation. As we do the algebra, a specific term just sort of emerges, one that looks and acts exactly like a probability. And this is what we call the risk-neutral probability.
And here is the formula itself. This is the absolute heart of risk-neutral valuation. Notice what's in it. the risk-free rate R, the time T, and the up and down factors for the stock, U and D. It's built entirely from observable market parameters, not from anyone's guess or opinion about the future.
So let's just plug in the numbers from our example. With a 10% risk-free rate, an up factor of 1.2, and a down factor of 0.8, the risk-neutral probability of an up move is precisely 0.7629. Again, this isn't a forecast, it's a calculated value that just makes the whole model internally consistent.
This brings us to a mind-bending, and I mean absolutely critical point. To price the option, we do not need to know the actual real-world chance of the stock going up or down. That's just someone's subjective forecast. The whole point of risk-neutral pricing is that it's completely independent of those forecasts, because the price is locked in by replication.
Okay, so now let's see what this powerful machinery can actually build. With replication and no arbitrage as our tools, we can derive one of the most fundamental and frankly elegant relationships in all of finance: put-call parity.
Let's consider two very different portfolios. Portfolio A has one call option plus an amount of cash equal to the strike price, discounted at the risk-free rate. Portfolio B has one share of the stock plus one put option. Now here's the cool part. If you map out the payoffs of these two portfolios at expiration, you will find they are identical no matter where the stock price ends up. And since both of those portfolios have the exact same payoff in the future, the no arbitrage principle demands that they must have the exact same price today. It's a must, and this gives us the famous put-call parity formula. Look, this isn't a theory or a model, it's a balance sheet identity. If it were ever violated, there would be a risk-free profit just sitting there for the taking.
Okay, now for the fine print. These are the kinds of details and distinctions that often show up in trick questions and really separate a passing grade from a perfect score. After that, we'll do a high-speed review of the most critical facts from this whole explainer.
A key distinction you have to master for any exam is European options versus American options. European options can only be exercised right at maturity. American options, on the other hand, grant the right to exercise at any point up to and including maturity. This early exercise feature adds this whole layer of complexity to their valuation, and it's a really frequent source of confusion.
All right, let's do this. A rapid recap of the 10 most critical, exam-worthy takeaways. Let's go. 1. No arbitrage is the core principle. 2. A key axiom is frictionless markets. 3. Replication is how we create synthetic options. 4. Self-financing portfolios isolate asset performance. 5. Risk-neutral P is a mathematical tool, it's not reality. 6. We price by discounting expected payoffs at the risk-free rate. 7. You have to know the formula for P. 8. Put-call parity is an unbreakable balance sheet identity. 9. You have to know the parity formula. And number 10, real-world stock return forecasts are completely irrelevant for pricing. Got it? Good. And that brings us to our final thought. We've just built this entire beautiful logical framework on the axioms of a perfect, frictionless market. But in reality, there are transaction costs, there are bid-ask spreads, there are market impacts. So the crucial question we're left with is, how do traders and quants adapt these fundamental models to account for all the complexities of the real world? That, right there, is where the theory meets the pavement.